Hello guys, welcome to this very short video about the addition rule and probability. We're going to take a look at the formula and a little example so that we can see how to apply it. So here we have the union of two sets, A and B, and suppose that we want to find the number of elements in the union of these two. So we want to know what is the number of elements in the union between A and B. So one way to do it is that we want to take all of the elements of, for example, set A. So these are all the elements in set A. Okay, so that is how many elements are in A. And then we also want to add all of the elements in set B. So for example, we're going to have all the elements here in set B. Okay, so we're going to add the elements of set B. But notice that in the middle, I have a section that got counted twice, and that's the intersection. This section was counted twice, once for A and once for B. So we don't want to count these elements two times, so we're going to subtract the intersection so that they only get counted once. And this would be the formula for counting the elements in a set. So similarly, the probability works very much the same way. So if I want to find the probability of the union of the events A and B, then the formula that I'm going to use is probability of A plus the probability of B minus the probability of the intersection between A and B. And this formula is derived directly from the counting of the elements, because if I divide each one of these numbers by the total amount of elements, then we get the probabilities. So that's where the formula comes from. So now let's take a look at this example where we're going to be applying the addition rule. A and B are two events such that the probability of A is 9/20 and the probability of B is 3/10. It is known that the probability of A united with B is 2 times the probability of the intersection of A and B. And now we have to find a couple of things here. So the union of A and B, the complement of the union, and A intersected with the complement of B. So let's begin with this property that they give us. Probability of the union of A and B is equal to the probability of the intersection of A and B. All right, now we can apply the addition rule here, and we know that this part, the left side, is going to be equal to probability of A plus probability of B minus probability of the intersection of A and B. And on the right, we still have 2 times the probability of A intersected with B. So all I did was take the union and replace it with the addition rule. All right, and now we can replace a couple numbers. So if we look back at the problem, we know that the probability of A is 9/20 and the probability of B is 3/10. So we can replace that here, 9/20 plus 3/10. And then we don't know what the intersection is, so I'm going to call it X is equal to, and again, 2 times, and we don't know what the intersection is, so I call it X. All right, we can do like terms by adding X to both sides of the equation, and we would have 9/20 plus 3/10 is equal to, and then 2x plus x is 3x. All right, so now let's figure out these fractions. Of course, we're going to need a common denominator, so we can multiply the second fraction by 2 for the common denominator, and now we're going to have 9 plus 6, which is 15, over 20, which is the common denominator. And to isolate x, now we can simply divide by 3. So we're going to have x on the right, and then 15 over 3 is 5 over 20, and we can simplify that to 1 over 4. Okay, so that means the probability of the intersection between A and B is 1/4. So now we know that the probability of the union of A and B is 2 times 1/4, which is going to be 2/4, which is simply 1/2. Okay, and this would be part A. So now let's look at part B. Part B is asking for the probability of the complement of the union of A and B. And this is simply taking 1 minus the probability of this set. So 1 minus 1/2, which is 1/2. Okay? So using the complement rule. And then finally, for part C, we're asked to find the probability of the intersection of A and the complement of B. So let's analyze this graphically. I have set A and I have set B. Okay, so let's look at, I'll do it in yellow. Let's look at set A intersected with the complement of B. So everything inside of A, but outside of B. So that's going to be this section. It's inside of A, but it is outside of B. All right. And now let's also take a look at, I'll do it in orange. A intersected with B is this part. And notice now that if I take the union of these two sets, so I think I'll write it here. A intersected with B. And if I take the union of this set with this one, then I'm going to have A. Okay? A intersected with the complement of B is A intersected with B. I'm sorry, united with A intersection with B is A. All right, so it's color-coded. And now, notice that that would make the probability of A equal to the probability of this part. Okay, and using the addition rule, that's going to be probability of A intersected with the complement of B plus probability of A intersected with B minus the probability of the intersection of these two sets. But notice that they don't intersect. The yellow and the orange never intersect. So there is no intersection, so we can just leave it like this. Equals the probability of A. And now we can isolate the probability of the intersection of A and B complement by subtracting. So we have probability of A intersected with B complement is equal to probability of A minus probability of the intersection. And then probability of A is 9 over 20. The probability of the intersection, if you guys remember from the first part, is 1/4. Okay, so we can multiply by 5 here to get a common denominator. And this is going to be 9 minus 5 over 20, which is 4 over 20. And we can simplify that to 1 over 5. Okay, so one of the things that you just saw is what happens when we have mutually exclusive events. Okay, so let's look at what that means. Mutually exclusive events are events that are disjoint. Okay, events whose outcomes cannot occur at the same time. So they have no intersection because they can't occur at the same time. And in that particular case, the addition rule gets simplified because there's no intersection to subtract. So the union of the events is going to be equal to the probability of A plus the probability of B. Okay? Because the intersection is 0. And that's it for this video.